So now we're thinking about our inferential task that is confidence intervals, and we're thinking about the situation where we have a difference in proportions. So the formula for standard error is this. So SE is equal to this square root of this whole thing, but we don't know P1 and P2. So the question is, what do we do? And the answer to that depends on the type of inference that we're making, but we're trying to do a confidence interval. That's what's happening in the CI section. So if we're doing a confidence interval, we can approximate P1 and P2 using P1 hat and P2 hat. So we're just going to plug in P1 hat wherever we had P1 and P2 hat wherever we had P2. And this is going to be the equation for our standard error. So recall that our generic confidence interval is we take our point estimate, that's our sample statistic, plus or minus a critical value, which is something that depends on the distribution and the alpha level, times the standard error. And in this case, our point estimate, our best guess for the statistic, is P1 hat minus P2 hat. So it's the difference of proportions. And then we have a plus or minus. Our critical value is a z star value, so we're back to using the normal distribution. And then we have our standard error, and remember, this is the formula that we're going to use for the standard error. And of course, we have all these conditions. We have to check the same conditions we did for one proportion, but scaled up, so there's kind of 4 things to check. So let's see an example. This is a sample from the General Social Survey. It's 100 adults, and we know the following. I've summarized it down into a two-way table. So instead of 100 rows of data with 2 variables, now I have a two-way table where I've got whether someone is self-employed or works for someone else, and whether they work for the government or they're a private employee. And we're going to try and find a 95% confidence interval for the difference in proportion of self-employed people between government and private employees. So this is similar to the kind of stuff that we did, I think, in Chapter 2 and also in Chapter P, where we have a table and we probably are going to need all of the marginal sums. So that's how I'm going to start. Maybe I'll sort of make myself a little bit of a box here, and then I'll give myself some space. I don't know if I'm going to be able to write small enough to write in those boxes, but we'll try to fill in those totals. So 1 plus 20 is 21, and 11 plus 68 is 79. Then 1 plus 11 is 12, and then 20 plus 68 is 88. And then I'll add down 12 plus 88, that's 100, and then 21 plus 79, just to check my work, that also turns out to be 100. So hopefully I did all my arithmetic correctly. And now I need to find a number of things. I think I actually had this on my next slide, but I'm going to need to find my point estimate. That's going to be a primary thing that I need to do. And in this case, I'm going to need P1 hat, and I'm going to need P2 hat. And P1 hat is going to be the proportion of self-employed people in government. And I'll call P2 the proportion of self-employed people who are private employees. So let's think. For this first one, we're going to have to think about what the bottom of our fraction is. And this is the proportion of self-employed people in government. So I want to stick to this government column and just think about the government column. So the bottom of my fraction is going to be the total for that column, which is 21. And then the top is going to be the number of self-employed people. So it'll just be 1. So 1 out of 21, or 0.05, I will round. And then P2 is the proportion of self-employed people who are private employees. So I'm going to stick to this column. So the bottom is going to be the total number of private employees. That was 79. And then the top will be the number of self-employed people, which is 11. And that turns out to be 0.14. I will round. So now I have P1 hat and P2 hat. My point estimate is actually going to be P1 hat minus P2 hat. And so let's do that subtraction. 0.05 minus 0.14. That's going to be negative 0.09. We could have done the subtraction in the other direction, but just because I started that way, let's go with that. Okay, so that's our point estimate. What else should I work on? Well, I'm going to need my standard error eventually, so let's do that. So my standard error is going to be the square root of P1 hat times 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat over N2. And I think I actually need to move some stuff around here. Scoot that over so it doesn't get smooshed in, and then I'm going to just close off my square root sign here. Actually, what I'm going to do is I'm going to copy all of this and I'm going to put it onto my next page where I think I have a little more room. So we've done step 1 is point estimate. I'm skipping critical value for right now, and I'm going to work on the standard error, and I've got my formula here. So I'm just going to plug in. So the square root P1 hat is 0.05. 1 minus 0.05, that's going to be 0.95. And this is going to be over the sample size for that group, which was the bottom of this fraction. So it's 21. Plus, and then I've got my P2 hat, 0.14, and then 1 minus 0.14, 0.86, I think. And that's going to be over 79. So maybe I'll just do those multiplications on the top of the fractions and then rewrite. I've got 0.0475 over 21 plus 0.1204 over 79. And then let's do that division. 0.0475 divided by 21. Oh my gosh, these are getting really small. Square root of 0.00226 plus 0.00152. And what's that going to be? 0.00226 plus 0.00152. It's going to be the square root of 0.00378 or 0.06 approximately. So that is my standard error. Maybe I'll draw some boxes to draw attention to the important stuff. So I've got my point estimate there. I've got my standard error here. So I've done the point estimate. I've done the standard error. Now we need to think about the critical value.